Digital twin technology. What is this digital twin technology and how does it work? A digital twin is a digital representation of a physical object, process, or service. A digital twin can be a digital replica of an object in the physical world, such as a jet engine or wind farms, or even larger items such as buildings or even whole cities. As well as physical assets, the digital twin technology can be used to replicate processes in order to collect data to predict how they will perform. A digital twin technology is, in essence, a computer program that uses real world data to create simulations that can predict how a product or process will perform. These programs can integrate the Internet of Things, Industry 4.0, artificial intelligence, and software analytics to enhance the output. With the advancement of machine learning and factors such as big data, these virtual models have become a staple in modern engineering to drive innovation and improve performance. In short, creating one can allow the enhancement of strategic technology trends, prevent costly failures in physical objects, and also by using advanced analytical monitoring and predictive capabilities test processes and services. If you have any question, you may contact on this, and the contents it includes is how does it work? How does it work? The life of a digital twin begins with experts in applied mathematics or data science researching the physics and operational data of a physical object or system in order to develop a mathematical model that simulates the original one. The developers who create digital twins ensure that the virtual computer model can receive feedback from sensors that gather data from the real world version. This lets the digital version mimic and simulate what is happening with the original version in real time, creating opportunities to gather insights into the performance and any potential problems. A digital twin can be as complex or as simple as you require, with differing amounts of data determining how precisely the model simulates the real-world physical version. The twin can be used with a prototype to offer feedback on the product as it is developed, or can even act as a prototype in its own right to model what could occur with a physical version when built. What challenges has it solved? Since it can be used across a wide range of industries from automotive to healthcare and power generation, it has already been used to solve a larger number of challenges. These challenges include fatigue testing and corrosion resistance for offshore wind turbines and efficiency improvements in racing cars. Other applications have included the modeling of hospitals to determine workflows and staffing to find procedure improvements. It allows users to investigate solutions for product life cycle extension, manufacturing and process improvements, and product development, prototype testing. In such cases, a digital twin can virtually represent a problem so that a solution can be devised and tested in the program rather than the real world.